The universe is far stranger than we allow ourselves to imagine, not simply in scale, but in the subtle, invisible rules that govern the dance of matter and energy across unimaginable distances. We have spent centuries peering at the sky, cataloging stars and nebulae, mapping the motions of planets, and gazing in awe at the glittering spirals and luminous clusters that we call galaxies. Yet, what if all the stories we have told ourselves about these colossal islands of stars are incomplete? What if the patterns we see, the rotations we measure, and the models we trust are shadows of a deeper, more complex truth that our instruments and theories have yet to reveal? Imagine that everything you learned about galaxies, their shapes, their behavior, their evolution, might be an approximation at best, a simplified version of a universe far more intricate and bewildering than we dared to imagine. For centuries, astronomers have sought to impose order on what often seems like chaos. We look at the Milky Way's spiral arms, gracefully arcing in a cosmic dance, and think we understand the rules governing their motion. We observe elliptical galaxies, vast clouds of stars in quiet symmetry, and assume we have grasped the story of their formation. And yet, the more we measure, the more anomalies appear, motions that do not match predictions, distributions of stars and gas that defy conventional gravity, and massive structures that challenge timelines for formation. These discrepancies are not minor. They hint that the underlying assumptions guiding our understanding may be fundamentally flawed, that galaxies may operate according to rules we have yet to fully comprehend. If this idea sparks a sense of awe, of curiosity, consider subscribing and joining a journey into the universe's deepest mysteries, where the familiar patterns of space are only the beginning of what we might discover. Perhaps the most confounding evidence comes from the rotation of galaxies themselves. In the 1970s, astronomers like Vera Rubin observed that stars at the outer edges of spiral galaxies moved far faster than expected, a discovery that shook the foundations of astrophysics. According to Newtonian physics, the visible mass of stars and gas could not generate the gravitational pull necessary to maintain such speeds. To explain this, scientists proposed dark matter, an invisible substance permeating galaxies, providing the additional gravitational force needed to hold them together. For decades, this idea has dominated cosmology, shaping models of galactic evolution, large-scale structure, and the behavior of the cosmos itself. And yet, even after decades of searches and simulations, dark matter remains unseen, detectable only through its gravitational influence, leaving open the unnerving possibility that we may be misinterpreting something far more fundamental about how galaxies work. Observations continue to complicate the picture. Some galaxies rotate in ways that even dark matter models struggle to predict. Others display intricate structures that simulations cannot reproduce, defying the timelines of formation that cosmologists have painstakingly calculated. Entire clusters of stars exist in isolation, spinning gracefully without apparent external influence, while others form astonishingly early in cosmic history, fully structured at moments when, according to prevailing theories, the universe should have been too young for such complexity. Each of these anomalies is a puzzle piece, and when put together, they hint at a universe far more dynamic and enigmatic than the neat models we often rely upon. If the notion that our understanding of galaxies could be fundamentally incomplete fascinates you, subscribing will ensure that you continue to explore these mysteries, following the twists and revelations as new discoveries challenge everything we thought we knew. Even the central black holes in galaxies, long assumed to form after the galaxy itself, now raise more questions than they answer. Some galaxies harbor supermassive black holes that are disproportionately large. Others appear to lack them entirely, and recent evidence suggests that black holes may not merely sit at galactic centers as passive anchors. They may actively shape the evolution of their host galaxies through jets, winds, and energetic feedback. These observations suggest a delicate, intricate choreography between matter, gravity, and energy, a cosmic narrative that we are only beginning to decipher. The more we look, the more we see that the universe is not a collection of static structures, but a living, dynamic web of interactions, And the more we realize how much we do not know, the more compelling the journey becomes. And yet, despite these confounding mysteries, there is beauty in the unknown. Galaxies are not simply objects to be measured. They are living, breathing testaments to the universe's creativity, elegance, and capacity for surprise. Their spirals, rings, and distorted forms are cosmic fingerprints, imprints of forces and histories we are only beginning to understand. The very act of questioning our assumptions, of peering deeper into the anomalies, transforms the familiar into the extraordinary. It reminds us that science is not a static body of knowledge, but an adventure, a process of discovery that stretches across both space and time. Every rotation curve, every unexpected structure, every star cluster moving against expectation is an invitation to explore further, to challenge the comfort of what we think we know, and to embrace the awe of realizing that the universe may be far stranger than even our boldest imaginations allow. And as we stand on the edge of this realization, facing galaxies that defy expectation, spinning and colliding in ways that unsettle our assumptions, it becomes clear that the story of the cosmos is not one we have fully written, but one we are still learning to read. Each observation, each anomaly, is a signpost pointing toward deeper truths, hidden structures, and possibilities that may fundamentally alter our understanding of existence itself. If the idea that everything we know about galaxies might be wrong ignites your curiosity, consider subscribing and joining this journey, because the universe's secrets are waiting, and the next revelation may change everything we thought we knew about the cosmos, about our place within it, and about the rules that govern the stars themselves. As we probe deeper into the cosmic architecture of galaxies, the apparent certainty of what we thought we understood begins to unravel, revealing a tapestry far more intricate and perplexing than the simple spirals and ellipses we grew accustomed to admiring. Consider the most basic assumption, that galaxies are relatively self-contained systems, their stars orbiting in predictable harmony around a gravitational center. Time and again, however, this notion falters under observation. Some galaxies exhibit motions that seem almost choreographed in defiance of gravity, where stars at the periphery move as if pulled by an unseen hand, while clusters in the galactic outskirts form patterns that challenge conventional physics. In some cases, the alignment of satellite galaxies around their host defies probability itself, hinting at an order, or a rule, beyond our current understanding, a cosmic logic we have yet to decipher. Then there is the enigma of galactic collisions, events we once thought straightforward in their dynamics. When two galaxies merge, our models predict a violent but comprehensible rearrangement. Stars slingshot around, gas clouds ignite new waves of star formation, and ultimately, the combined system stabilizes into a new configuration. Yet observations tell a more complicated story. Some collisions produce structures that seem impossibly stable, while others yield chaotic remnants that defy simulation. Entire galactic filaments stretch across space, suggesting that the interactions between galaxies are not merely local events, but part of a larger cosmic web, a lattice of matter and gravity spanning millions of light years, binding structures together in ways that challenge both intuition and calculation. The more astronomers map these interactions, the more it seems that we have only scratched the surface of the forces shaping galaxies, forces that may operate at scales or in ways we have yet to fully comprehend. And just when we begin to grasp these challenges, new anomalies appear, strikingly inconsistent with conventional theory. Some galaxies rotate too quickly to be held together by their visible matter, even with dark matter accounted for. Others appear surprisingly early in cosmic history, fully structured when our models suggest they should be chaotic clouds of gas. There are galaxies with cores that are far more massive than their size would predict, while others seem to lack a central black hole entirely, defying the long-held assumption that supermassive black holes anchor every galaxy. These contradictions are not minor footnotes. They are signposts that the models we rely upon may be incomplete, that galaxies are far less uniform and far more complex than the neat categories we have created for them. If the thought that our understanding of the universe might be fundamentally flawed intrigues you, Subscribing ensures you are part of this exploration, following the unfolding story as each new observation bends what we thought we knew. The mysteries do not end there. Galaxies are not just shaped by their own gravity or by collisions with neighbors. They exist within a larger, dynamic cosmic ecosystem. The distribution of dark matter, the influence of cosmic filaments, and the unseen scaffolding of the universe all interact with galaxies in ways that are only beginning to emerge in simulations and observations. Entire swaths of intergalactic space, once thought empty, are populated with streams of gas, dust, and unseen mass, connecting galaxies over vast distances. In this context, each galaxy is not a discrete island, but a node in a sprawling cosmic network, a single piece in a puzzle whose full picture remains tantalizingly out of reach. The challenge is not only to understand individual galaxies, but to comprehend how they are woven together into an ever-changing, interconnected cosmos. Speculation begins to take root as the anomalies mount. Some theorists have proposed that perhaps the laws of gravity themselves are different on galactic scales, a radical idea that suggests that our assumptions, grounded in local observations within the Milky Way, may not apply universally. Modified Newtonian dynamics, or MOND, proposes tweaks to gravity at low accelerations, offering an alternative explanation for the rotation curves of galaxies without invoking dark matter. Though controversial, these theories highlight a profound truth. The universe may operate according to principles that we have only partially glimpsed, and the apparent contradictions we observe are not mere errors, but clues to a deeper, underlying reality. Every spiral that spins too fast, every elliptical that seems too early or too massive, becomes a whisper from the cosmos, inviting us to rethink what we thought we knew. Beyond the mechanics of rotation and collisions lie questions of origin and evolution that challenge long-held narratives. Galaxies appear to form faster than conventional models allow, achieving structural complexity mere hundreds of millions of years after the Big Bang. How could such intricate systems arise so early, when the universe itself was in its infancy? Are these galaxies exceptions, outliers in a statistical sea, or are they evidence that our understanding of cosmic evolution is incomplete, that the processes driving the assembly of stars and gas operate on principles we have yet to grasp? Each discovery seems to undermine the comforting narrative of gradual, predictable development, replacing it with a story of a universe that is both more chaotic and more elegant than we imagined. And just when we think we have accounted for the anomalies, new puzzles emerge from the most unexpected corners. Some galaxies display rings, warps, or asymmetries so pronounced that they cannot be explained by standard models of rotation and mass distribution. Others host clusters of stars that appear older than the galaxy itself, a temporal contradiction that challenges our understanding of galactic chronology. Even the interplay between black holes and their host galaxies is stranger than anticipated. Jets of energy, bursts of radiation, and cosmic winds appear capable of regulating star formation across millions of light years, linking the fate of central black holes to the evolution of entire stellar populations in ways that are only beginning to be explored. These revelations suggest that the universe is not merely stranger than we imagine. It is stranger than we can currently quantify. It is here, in the intersection of observation and speculation, that the true wonder begins. Galaxies, far from being predictable star cities, may be dynamic systems operating under rules we have only glimpsed in fragments. They may interact with unseen forces, hidden dimensions of matter or energy, or even subtle properties of space and time that we have yet to recognize. Every anomalous rotation curve, every early forming galaxy, every massive black hole that defies expectation is a thread pulling us toward a larger, more profound understanding of the cosmos. And yet, each thread also reminds us how little we truly know, and how much the universe still resists our attempts to fully map its contours. If the idea that the universe may be far stranger and more interconnected than we have imagined captivates you, then subscribing will allow you to continue this journey, following each new discovery as astronomers push the limits of observation, theory, and imagination. The anomalies we have discussed are not dead ends. They are invitations, pointing toward questions that will occupy humanity for generations. They remind us that the act of exploration is as important as the answers we seek, and that the universe rewards curiosity with revelations far beyond the simple beauty of a spiral or the quiet symmetry of an ellipse. As we contemplate these mysteries, it becomes clear that galaxies are not simply objects to be catalogued. They are dynamic, evolving, and perhaps even semi-autonomous entities within a vast cosmic network. They are witnesses to processes that unfold over billions of years, shaped by forces both visible and invisible, bound by gravity yet liberated by unknown rules. To understand them fully is to confront questions about the nature of matter, the behavior of gravity, the origins of structure, and perhaps even the limits of human knowledge itself. And yet, it is in this confrontation that the thrill of discovery emerges, a quiet but insistent reminder that the universe is far richer and more enigmatic than the frameworks we have built to contain it. If we allow ourselves to follow the anomalies and contradictions to their logical extreme, the picture of galaxies transforms from neat, self-contained star cities into something far more complex, almost alive in its unpredictability. Imagine galaxies as not merely collections of stars, gas, and dust, but as dynamic systems in conversation with the universe itself, responsive to forces both visible and invisible, interacting across vast cosmic webs that span millions of light years. Each galaxy could be influenced by subtle ripples in space-time, streams of dark matter we cannot detect directly, or even processes at quantum scales that manifest in aggregate motion over billions of years. In this vision, every spiral arm, ring, or warp becomes not just a structure but a message, a signpost of deeper, hidden interactions shaping reality on scales both immense and intimate. If the thought of following these hidden threads through the cosmic labyrinth excites you, consider subscribing. Together, we can trace the mysteries that weave galaxies into a universe far stranger than we ever imagined. Speculation naturally grows bolder when we consider the earliest galaxies, those that appear fully formed when the universe itself was barely a fraction of its current age. What could have caused such rapid development? Are we missing key processes of star formation, interactions between dark matter and normal matter, or even exotic physics that operate only under conditions found in the early cosmos? Perhaps the conventional timeline of galactic evolution is an approximation, accurate only for certain environments, while other mechanisms operate under unknown rules, producing galaxies that defy chronology, size, and structure in ways our current models cannot predict. Each of these possibilities opens a door to realms of understanding that challenge everything from gravity to cosmology to the origin of the very matter we are made of. Then there is the possibility that galaxies are not independent, isolated entities at all, but nodes in a vast cosmic network, connected through invisible filaments of dark matter, energy flows, or even dimensions we cannot directly perceive. This network might operate like a neural web, in which the behavior of one galaxy subtly influences another, where rotations, collisions, and formations are coordinated by rules that are not yet apparent to human observation. If true, our conception of the universe as a collection of individual galaxies must give way to a vision of the cosmos as a living, interacting system, with galaxies as its neurons, each contributing to a pattern that we are only beginning to glimpse. The implications are profound, not just for physics, but for philosophy, for how we conceive of causality, connection, and the very nature of existence itself. Some scientists even speculate that the anomalies we observe, early formed galaxies, unexpected rotations, oversized black holes, might hint at unknown forces or at new physics altogether. Could there be fields, particles, or dimensions influencing galactic behavior that our instruments cannot yet detect? Could gravity behave differently on intergalactic scales, bending, warping, or even looping in ways our equations do not account for? These ideas border on the speculative, yet they are grounded in observation. The universe continues to present evidence that defies expectation, demanding bold hypotheses to match its complexity. Each new telescope image, each spectral analysis, and each simulation pushes us closer to a reality that may be stranger than any theory conceived in human imagination. And as we contemplate these possibilities, the philosophical weight of the universe becomes apparent. If the structures of galaxies are not fully governed by the rules we understand, then our perception of order, causality, and predictability may be provisional, local, and incomplete. The universe is far larger and more subtle than the frameworks we have built to contain it, and the anomalies we observe are invitations, guiding us toward humility, wonder, and the recognition that our knowledge is always incomplete. To acknowledge this is not despair, it is exhilaration. It is the awareness that the cosmos contains surprises at every scale, and that each revelation, each puzzle, is an opportunity to expand not only our understanding, but our imagination itself. If this sense of wonder calls to you, subscribing allows you to follow the next discoveries, the next anomalies, the next insights that may redefine how we think about galaxies and ultimately about our place in the universe. Finally, let us imagine the cinematic sweep of this vision. Vast spirals rotating silently in the dark, elliptical giants glowing with the light of billions of stars, clusters forming intricate patterns across cosmic filaments, all interconnected in a web of invisible forces. The familiar becomes alien, the orderly becomes mysterious, and every observation is a hint of something far deeper and more intricate than our instruments can fully capture. The galaxies we have long admired for their elegance may, in fact, be gateways into understanding a universe that is alive with patterns, interactions, and hidden rules, revealing a cosmos that is at once more beautiful, more enigmatic, and far more profound than we have dared to imagine. And as we step back to contemplate this vision, we are left with the quiet, breathtaking realization that the story of galaxies, and of the universe itself, is not written in stone, nor fully accessible to human comprehension. Every spiral, every elliptical, every anomaly is a reminder that reality stretches beyond our current understanding, inviting curiosity, imagination, and exploration. The universe is far richer, stranger, and more interconnected than we have imagined, and the journey to understand it is only beginning. If you feel the pull of this journey, if the mysteries of galaxies call to the explorer within you, subscribe, and let us continue together, tracing the hidden threads of the cosmos, following anomalies, revelations, and discoveries as they unfold, and witnessing a universe that is more wondrous, more complex, and more alive than we ever dreamed possible. In the end, the galaxies are not merely collections of stars, but living stories etched across the canvas of the cosmos, whispering secrets we have only begun to decipher. They challenge us, humble us, and inspire us, urging us to question what we think we know and to embrace the vastness of possibility. And as we look up at the night sky, with its countless spirals, clusters, and filaments stretching beyond imagination, we are reminded that every anomaly, every puzzle, and every unexplained motion is an invitation to explore, to wonder, and to follow the universe wherever it may lead. The galaxies, in all their mystery and majesty, are calling. If you are ready to answer, subscribing ensures you will not miss a single revelation, a single twist, a single glimpse into the truths that lie beyond what we think we know about the cosmos.